We'll go to where, like, right.
I'm not.
Okay, guys, page 7. All right, guys, page 7. Let's start off with 17. Did we do 17 yet? No, okay. Okay, I'm going to start with 17 though. Okay, guys, page 7. Okay, so we are going to simplify the expressions to either 1 or -1. Just as a review, we have even and odd functions. Cosine and secant are even, but the other 4 trig functions are odd.
I'm gonna go to sleep today. Kidding.
So odd functions, we're just going to push the negative out in front. Okay, so look at 17 here. Sine x, we don't have to do anything with that, but cosecant of -x, we can convert that to be what? Right, so cosecant is odd function, so that negative, we can just drag that out in front. We know that sine and cosecant are reciprocals of each other, so it's just sine times 1 over negative sine, which is -1. All right, 19. Cotangent. Anything? Can we do anything with cotangent here? Cotangent is even or odd? Odd. We can pull that negative out in front. And then cotangent of pi over 2 minus x. This is just saying that there is a shifted version of cotangent, and the shifted version of cotangent is just tangent. Since cotangent and tangent are reciprocals, they're going to cancel it out to be 1, but then we're going to hold on to negative. Right, 21. Okay, I think it's easier if we put these exponents out, just so we can kind of see. So I'll use brackets, but I want to see the exponents outside so we can kind of see the effects of the even and odd functions. Okay, so what do you know about sine here? Odd, so we can pull that negative out in front. So I'm going to have this as. What about the cosine? Even, so it just disappears. So the negative's here, but what's negative times negative? Positive, right? So this is just going to end up being sine squared x plus cosine squared x. So there was a negative that came out, but then that negative is being squared overall. So it ends up back to sine squared plus cosine squared, which we know is 1. 19 is -1. Okay, 23. Tangent of pi over 2 minus x. We can do something with this, right? Tangent of pi over 2. That's cotangent. We know tangent and cotangents are just shifted versions of each other. All right. Understand that cosecant squared x is just cosecant of x times cosecant of x. Okay, what's going to happen here? We can take out one of the cosecants. So cotangent over cosecant. What can we do to make it a little bit easier to visualize here? Cotangent is, how about getting everything in terms of sine and cosine? Cotangent is equal to what? Cosine over sine. All over 1 over sine. Okay. Dividing by the reciprocal, the same thing as dividing by a reciprocal, the same thing as dividing by a fraction, the same thing as multiplying by the reciprocal. Sines cancels out. We're left with cosine. Yes.
Can you explain 21 again?
Sure. 21. Sine square negative x. If I drag that squared outside, I have sine of negative x squared. We know that sine of negative x is an odd function. So I can pull the negative out in front. So it's basically negative sine of x times negative sine of x is what is happening with that square. So the square is going to force that negative to be positive because I'm basically multiplying two negatives together. So that's going to bring me back to a positive sine squared.
So what was the answer?
Yeah, oh, it's 1.
For 23?
Oh, 23 is cosine of x. Okay, let's go to page 8. Okay, we're still going to be using the same identities. It's just the problems are going to be a little bit more involved. So I'm going to walk you through every problem. We're just going to get through this page and take it step by step. Okay. Okay, so the first one here says, tell whether or not sine of x is an identity. So all we're going to do is we're going to try to get this down to hopefully looking like sine of x. So what can we do with tangent? Sine over cosine. Secant of x, 1 over cosine. Complex fraction looks messy, but we know we can always drag that denominator up, multiply by the reciprocal, and let's see if we can get anything to work out. All right, what happens here? Cosines goes away. We're left with sine of x. Right, so this does prove that it's an identity because this does work out to be just sine of x.
What if it wasn't an identity?
If it was an identity, then we just say that it's not a, like if this ends up being cosine of x, then we know it's not an identity, right? We can see clearly that it doesn't work out to match what it's supposed to be, then we know that's not an identity. So number 2, these problems moving forward, these are true statements, and we're just trying to prove from one side to the other. Typically, what we do is we just work from the left side and try to get it to look like the right side. We're not going to be adding and subtracting from both sides of the equation. So think of it as we're just going to be working from the left side moving forward. And then after we clean up, apply properties, apply identities, we know that we've reached the end if we can get this left side to look like the right side. Okay? So don't think of it as an equation where we're going to solve anything. Okay? We're just trying to We're just going to work with this expression to try to make it look like the expression on the right. Okay. So here's number 2. First things first, I like to just get rid of the parentheses. But before we do that, though, let me see. Look at the left side and look at the right side. What is the right side all in terms of? Cosine and sine. So maybe we can start converting some of these to be in terms of sine and cosine. That way we know that, you know, there's only 2 functions involved here. So let's just convert everything to be in terms of sine and cosine. We can do that because we have these reciprocal and quotient identities. So I'm going to leave that sine of x outside for now. I'm going to start converting each of these terms inside. So cotangent is cosine of sine. Okay, so I'm just converting that cotangent. This cosine is good to go, but what can we do with this tangent? So no cosine. Okay, I want to distribute the sine through, but maybe there's some cleanup that we can do beforehand. See anything here? What can we do? Yeah, let's just get rid of the cosine. Just makes it one less thing to worry about. Now let's distribute the sine through. Okay, so if I distribute the sine through, I'm just going to multiply the sine times cosine over sine. What's going to happen here? Just cleans up to be just what? Just cosine. Okay. We further distribute the sine to the second term. Sine times sine, sine squared. Okay, have we reached the end? Yes. Okay, so we know we've reached the end when we can get our expression to look like the right side. So what we're going to do is we're going to keep kind of going back and forth. Each step that we take, we're going to see, all right, are we making progress? Does it look more like the expression on the right side? And we're kind of have to go back and forth in the hopes that we can eventually get to that right side. Okay. All right, question with 2. Okay, number 3. Cosine of x minus sine of x quantity squared. We want this to eventually turn into this. First thing I'm thinking of is what can we do to maybe get rid of the parentheses? Careful here. Can we just take this exponent and distribute through? We have to write this out twice. Okay, we have to make sure that we're actually foiling our expression out. Okay. Otherwise, if we just distribute the square through, we're going to be missing out on a couple of terms. So we're going to write our expression out twice. And we're going to FOIL our way through. Okay. Cosine squared. Distributing through here. Minus cosine x sine x. Keep going. Minus sine x cosine x. And then plus what? Sine squared x. Okay. Yeah. Okay, we haven't quite reached the end yet, but look at what we have. Do we see any cleanup opportunities here? Good. So we know that's an identity, right? Sine squared plus cosine squared equals 1. That's good. What else?
Add the negative.
Right. We know those are like terms, right? I know the order is not the same, but cosine sine is same thing as sine cosine. So we get negative 2 cosine x sine x, right? So like you said, sine squared plus cosine squared is 1. 1 minus, and then this becomes okay, we've reached the end because we made it match the right side. All right, number 4 is a little messy, but we'll walk through it step by step. Okay, we'll go slow. Okay, number 4, tangent of x plus secant of x. We want this to turn into cosine over 1 minus sine x. What do you think is a good first step? Good. Yeah, let's just get that sine and cosine to show up. We may have to deal with some fractions, but we'll deal with it. We'll deal with common denominators. But let's just at least get it to begin looking like the functions that are showing up on the right side. Okay, so tangent is secant is 1 over cosine. Okay, what's nice about these fractions? Okay, they already have the same denominator, so we don't have to balance the fractions. It's nice. The other problems are not going to quite be as clean as this, but for now, we know that this will be a faster process there. We're just going to combine those together and make it sine of x plus 1 over cosine of x. Okay, so let's see what we have versus what we're looking for. At least we have the same trig functions, but it's not quite looking like the denominator, or at least, yeah, it looks like numerator and denominator are kind of like flipped. So we don't have an identity right now because we don't have cosine or sine squared. We're already dealing with, we already are in the same functions. So it's going to kind of seem strange, but we're going to introduce something so that we can force an identity to be used. So I'm looking at that cosine, and I know that whatever I do to the denominator, I can, as long as I'm matching it to the numerator, I can, I'm not breaking any rules, and I'm maintaining the value of my fraction. So if I can force it to be cosine squared, then maybe something can come out of it. So I'm introducing something into the problem so that I can kind of jumpstart that denominator, because I want that denominator to convert to sine, and I'm hoping that cosine squared will help me get there. But anything I do to the denominator, I got to make it match in the numerator, otherwise I'm changing the problem. Okay, so I'm going to multiply the denominator, but the numerator, I'm going to keep it separate. I think it helps just to, because I've got sine x plus 1. If I keep it separate from cosine of x, I think that will be a good thing for later on. Okay, I know that we're not in the same function in the denominator, cosine squared x. We want 1 minus sine x, but we can make some progress at least, right? What can we do with cosine squared? Yeah, 1 minus sine squared. So at least we can get it in terms of sine. Let's see what we can do from there. Okay, I don't want to lose anybody, so any questions? We see every step along the way. Yeah, question.
Cosine 2x.
Oh, how'd I get there? So I started with cosine of x. I wanted a trig identity to be used. So I'm going to introduce cosine into my problem so I can get cosine squared. Because I can get cosine squared, I have a way to convert to be sine squared. So I multiply the numerator and denominator by cosine. I'm introducing cosine into the problem because I want to jumpstart something to begin changing that denominator. Well, we're forcing it into the fraction so that it doesn't cancel out, but we're doing cosine over cosine because we don't want to change the problem.
Oh, instead of cosine over 1, you're doing cosine over cosine.
Exactly, right. Because I don't want to change the fraction. If I just do 1 over cosine or cosine over 1, then it's a different problem than what I'm working with. Okay, so we have 1 minus sine squared x. At least we have the same trig function in the denominator, but it's not quite the same. Any idea what we can do with that 1 minus sine squared? Factor, good. Difference of squares, right? Perfect squares there. We can break that down into 1 minus sine x and 1 plus sine x. You see that? We practiced that yesterday, right? Sometimes recognizing that difference of squares can be helpful. And then we look at the numerator. Now we see some matching parts. So we're left with cosine of x over 1 minus sine of x. Okay, are we done? Yes.
How did cosine squared x into 1 minus?
Good. So the reason why is because we're always looking for identities to apply. If we know that sine squared plus cosine squared equals 1, then if I rearrange it, I can get 1 minus cosine squared to be sine squared. Right, so anytime I see a cosine squared or trig function squared, I'm always going to at least be considering maybe there's something I can replace using one of the identities to kind of help me move forward in my problem. Okay, good. That's one of the tougher ones because we kind of have to make something out of nothing there to kind of create that identity there. Okay, any questions with 4? Okay, let me recap the steps. We saw that the left side was not the same trig function as the right side, so we made our steps to convert tangent and secant in terms of sine and cosine. And then we realized that there were some fractions that need to be resolved, so we got it into one fraction. Once we're here, we realized that we were at least in the same trig function, but it's out of order. We need the denominator to show sine. So I want to get that cosine to show sine. The way I do that is I can maybe force that into an identity that I can use. So if I multiply cosine into it, I can make it cosine squared. If I make it cosine squared, I now have that Pythagorean identity to play with. And then factor and reduce. So it's a lot of steps here, but we've seen a part of it from yesterday. So we're kind of just building and building in terms of the things that we see. Okay, questions with 4? Okay, let's look at number 5. Okay, we're starting on the left side and moving to the right side. Okay. I know I have to start with the left side. Is there anything that I can, does the numerator remind you of anything? I have an identity to work with here. I know that secant squared minus 1 is equal to tangent squared. So at least that gives me a starting point to work off of the left side. Okay, it doesn't seem like we've made a lot of progress here, but what can we do with tangent? Because if you look at the right side is all in terms of what? So sine. I know that a cosine is going to show up, but at least we're able to get a sine to show up, right? So let's get that tangent to be what? Sine squared over cosine squared. All over. Okay, we're making progress. There's still that cosine squared, but we can deal with it later. We know that cosine squared can automatically be converted, right? So we know that at least it's a lot easier working with cosine than tangent. We know cosine can be converted to be sine. Okay, dividing by a fraction is the same thing as multiply the reciprocal. I can get that sign to come up. Okay. Any progress here? What do you see? Cancel one of the signs. So let's see what we have left. We have sine of theta over cosine squared theta. Are we at the end? Well, we're close, right? We're close. Cosine squared, can we convert cosine squared to be in terms of sine?
Yes.
Yes, we have that identity, right? We know that cosine squared is equal to 1 minus sine squared. So if I do that, then I'm able to get that right side to match. Okay, I want to go as slow as you need to, so please ask questions if you want me to go over any steps that doesn't quite make sense for you. Okay, are we good with 5? Okay, number 6. All right, this is a little messier here. Number 6, we want to eventually combine this to make it look like 2 cosecant squared x. I have 2 fractions, so what are you thinking here? Yeah, let's try to merge them into the same fraction, but if we want to merge it, we need common denominators. So common denominators, I need to create a denominator that both original denominators can go into. What do you think my common denominator would be? Okay, I'm going to need 1 minus cosine x, and I need 1 plus cosine x, right? I need both expressions to create my common denominator. Okay, so
Yeah, what's the answer for 5?
oh, 5 is just sine of theta over 1 minus sine squared. We're just trying to make the left side match the right side. Okay. Okay, denominator is going to look a little long here because we have both parts making up the common denominator. Okay, I like to write it out twice so I can kind of see exactly what's missing between my old and new denominator. So I'm just look at the first fraction here. Anything change between the old first denominator and the new denominator? What am I missing here? 1 plus cosine x, right? Okay, so I need to balance the numerator with a 1 plus cosine of x. If I multiply that with times 1, then I'm still left with just 1 plus cosine of x. Okay, what about the second denominator and the new denominator? Yep, so I need to multiply this fraction numerator by 1 minus cosine of x times 1 is just going to be. Okay, so now the advantage is that we can merge the 2 fractions together because now I can add the numerators and the denominator will stay the same. So if I merge them together, what's 1 plus 1? Cosine minus cosine, 0. So I'm just left with 2, right? 2 in the numerator. I'm going to recopy the denominator, okay? Sorry, I can zoom in on this. Okay, are we good up to this point? Now, if we look, at least we have the numerator matching, right? We still haven't got that cosecant square going, but what can we do here? Let's expand this out, right? Expand it out. It doesn't, maybe it's not going to quite look like cosecant squared, but maybe sine squared will work out. So if I multiply this out, I'll put all the steps here. This is 1 minus cosine of x plus cosine of x minus cosine squared x. So we know the middle terms will drop out. I'm just left with 1 minus cosine squared x. Okay. Making some progress here. What's 1 minus cosine squared x? Yep. So 1 minus cosine squared x is sine squared x. So let's see. Will that help us get to our answer here? So close to, I'm trying to aim for 2 cosecant squared x. I have 2 over sine x, sine squared x. What's the relationship here? Right. So what if I just flip that sign up to the top? If I flip to the top, I can just make it cosecant squared x, right? Because we know sine and cosecant are reciprocal, so I can just make it flip and change the name of the function. So if you want to see the full steps here, maybe I can just write it this way. If you think of it as 2 over 1 over cosecant squared x, if you want to see that full relationship, you know that sine squared is 1 over cosecant squared x, and then just think of it as, okay, I'm just multiplying by the reciprocal. You can think of it this way as well. Okay, if that helps you see the relationship a little better. Okay, all right, just 2 more problems. Number 7, let's see. I want to make sure I don't go too fast. Any questions with 6? Yeah.
When you give the negative cosine 2x, like how do you get rid of the negative?
Oh, you mean this one here?
Yeah.
So we have a special relationship here, right? I'm always going to go back to my identity to see if I can do something with it. So 1 minus cosine squared is just sine squared. Good. Any other questions? All right, number 7. Sine squared minus cosine squared equals 1 minus 2 cosine squared. Okay, look at what we're going to start with and look at what we're going to end with. Everything on the right side is in terms of what? Cosine. So maybe I can do a little bit of work with this. What can I do with this? Yeah. Let's see if that will help us out. So we know sine squared is just equal to 1 minus cosine squared alpha. You can, if you want to use theta or x, that's fine. I'm just going to keep this variable here. Okay, I think we're making progress here. We can drop the parentheses because there's no negative outside. So what's 1 minus cosine squared minus cosine squared? Okay, so are we at the end?
Yes.
Yeah, okay. All right, one more. Any questions with 7? Okay, let's look at number 8. Number 8, we're looking, we need to start on the left side. We're trying to end on the right side. They look nothing alike, but maybe we have a denominator here, so we can merge them together, but we got to do what if we want to do that? Look for a common denominator, right? Because I have that 1 over tangent. I can make that second a fraction, tangent over 1. All right, so what's my common denominator? Tangent of b. Okay, we're going to look to balance each of the fractions. Any changes with my first fraction? No, just bring down the 1. Any changes with the second fraction? Yeah, I need a tan. So because of that balance, I need to multiply tangent b times tangent of b. Okay, I'm going to merge them into one fraction. All right, do we see anything that we can do with that 1 plus tangent squared? Okay, good. At least we have something that's beginning to look more familiar from the right side, so we're making progress there. Okay, so the secant is showing up. We still don't have cosecant. What do you think we can do next? Yeah, let's get that tangent to be sine and cosine. I know sine and cosine is not quite secant and cosecant, but at least we know they're reciprocals, right? So we know that we can work with that. Dividing by a fraction, we can multiply by the reciprocal. So I multiply by the reciprocal. I still am not seeing secant and cosecant on this side, but I can just create the reciprocals for them, and then I can, because I can convert cosine to be in terms of secant, I know I can convert sine to be in terms of cosecant. So if you want to see the full steps here, I'm going to make that cosine into 1 over secant. I'm going to make that sine into 1 over cosecant. And I'll just do a quick little multiply by the reciprocal and see if I can get that to work out the way I want to. So this just turns into what? Cosecant over secant, right? So I just converted this into cosecant over secant. I'm going to drop down and see if I can get this to work out the way I want to here. Okay, so at least we have all the correct functions showing up. Okay, what's our last step here? Okay, are we at the end? Yes. Okay, any questions? All right, I'm gonna walk around, see if you have any questions. Also, leave your worksheet out. I just want to check your page 7 and page 8. Okay, page 7 and page 8.
Yeah, it's fine.
Yeah, we didn't actually get it. Is it actually? Yeah, that's what I watched.
I just said one.
It's like at this big problem.
You could just it's just I work on
Yeah.